How do you make it light up?
You put it on this thing.
So you put one wire on each side of the battery?
Mm-hmm.
And what happens if you take it off? You guys, check this out. We're going to light it up with this kit. You've seen this technology in toys, greeting cards, games, and more, and now we're bringing it to you. In this installment of Subscription Science, we're having fun learning about electricity by making paper circuits. Once you figure out how it works, the only limit of what you can do with it is your imagination. We'll start off by making a simple circuit and then show you an example of an art project we made using these paper circuits. But first, let's look at the materials you're going to get in your kit as well as the things you'll need to have on hand at home. Okay, we're going to send you a length of copper tape. This is the real hero of the story. This is essentially just copper wire with an adhesive side so that you can stick it to paper, cardboard, or anything else. This can also be purchased on Amazon if you decide you want to do a bigger project and need more. You could probably get it at Walmart, maybe, or hobby stores as well. We're also sending you a flat battery and an LED bulb. Colors vary. Note that while all of the stuff we're showing you today uses the LED bulbs, you can also wire things like buzzers or sound makers to these circuits as well, all of which can be purchased online or at hobby stores. You'll also get a paper clip and a brass brad, which you can incorporate into projects. We'll show you an example or two. And finally, at home, you'll need to have scissors, tape, and paper. All right, let's get started.
Not broken.
Can you make it light?
I can't make it with me.
Squeeze it. Squeeze the things on there.
Why won't it work?
Oh, switch. Maybe turn the bulb around. Or turn the battery around.
Yes.
Oh, look at that.
Look.
So you had to have it going the right way.
Yeah, we don't have it going the right way. And you can still walk it this way.
Yeah, what color is it?
It's blue. Is it blue?
I don't know.
Orange?
Or?
Purple.
I don't know. Let's try.
Pink. Grape.
Grape.
Like red and green and purple.
Oh.
A strawberry flavor. It's on. Oh.
Turn it around. Oh!
Green. I was right. It's green like.
Green like a grape?
Yeah.
All right, so trace it.
I'm doing it really carefully.
Okay. Left-handed. Wow, left-handed. That's pretty good.
Done.
Okay, now put the battery, yeah. Now fold it over and try to trace where it is now.
So they're white?
Yeah, that's pretty good.
It's kind of bigger.
That's okay. Now, kind of color that circle in maybe.
Okay. It's okay like that.
All right, now fold it back. Yeah, there you go. Now fold it back down. Okay, and can you trace it again?
It's okay.
Okay. All right. Once you've figured out where the battery will be placed, you can build your circuit. It's probably a good idea to draw it out, but in this case, Emmett here is just kind of shooting from the hip, but we did give him some suggestions as to how to lay it down. It's also worth saying that the tape can be frustrating to work with, especially for little fingers. It tends to curl and stick to itself, so adult help is a great idea. One nice thing about this particular brand is that it's conductive on both sides of the tape, which makes it a little simpler when laying out your circuit. When it comes to corners, bends, and branches, you can either cut the tape and lay down new sections as we've done here, or you can fold the tape over itself to change directions. Another important thing to remember is to leave a space for your bulb. You can do this by having a short break in your circuit or a space where there's a gap between sections of tape. The wires from your bulb will make contact with the tape on either side of the break. Also, look out for short circuits or sections where the copper tape touches spots where you don't want it to go. You can also see here that we have one section of tape going through each of the circles representing the battery placement. Since one side of the battery is positive and the other is negative, you need to make sure that each side of the battery is making contact with the tape at one end of the circuit. The circuit is closed and the light goes on when you press the tape into the battery with firm contact. We'll show that in a bit.
There it is.
All right, let go of the button. Now press it. You did it. What is?
It's so blue before.
It's blue. Let go of the button. Oh, the battery back.
Oh, slip.
It slipped. All right, do it. So take your finger off the.
So the juice is going here to here to here to this, and then it goes up here. Juice goes up to here, so the light can produce light, so it can shine.
Very good. So the juice, or do you know what we really call the juice?
What?
Electricity.
Yeah, the juice is electricity.
Yeah. But
Lightning is electricity, so it goes into there. We call that electricity, but it's actually juice.
yeah, kind of like that.
It goes into the wire,
Yeah.
and it's you gotta be really careful with wires. So you plug it in, and you put this thing into your phone, and then it charges.
Yeah.
The Apple when you know when it's done.
That's right.
And electricity makes this,
Yeah.
and this is a wire. It's tape, but it's kind of like wires.
It is a wire. It's a
There you
tape.
go.
It's tape wire.
There you go, like
Yeah, we
glue.
call it circuit tape. So, here, take your finger off the battery for a second. So what happens is there's electricity. This battery kind of has two compartments inside of it, right?
Like there's two compartments.
Yeah. And
This
the
compartment and this compartment.
yeah, one on one side of the battery and one on the other. And the juice, the electricity wants to flow from one compartment to the other, from one side of the battery to the
this
other.
one and this one.
Yeah. And see, when you have it open like this, the juice can't get all the way back to this side, right?
Because if you squeeze it, if you squeeze it, the juice comes out like orange juice.
Kind of like that, but yeah, not exactly like that, but that's the right idea.
You go
So
like
when we
this.
do that, now the juice and the electricity can flow from one side of the battery back to the other side, right?
It's like a loop-de-loop.
It is like a loop-de-loop. Do you know what we call it?
What?
We call it a circuit.
Yeah, a circuit is
What?
cool. It's magic, but
Well,
electricity.
it's science. It's not magic.
It's science, but
What shape does the word circuit remind you of? What shape? Think of the shapes that you know. Circuit. What does it sound like?
circuit, triangle.
Well, no, not triangle.
Oh, circle.
Yeah, circle. So what have to happen is basically the electricity has to flow in kind of a circle, right?
Yeah, like
It goes
that's
from
why
one
we
side of the battery
that's
to the
why
other.
That's why we draw the circle.
Yeah, kind of. And if you open it, then
And that's why we made it like this.
Well-
And that's why they made it like this.
you're thinking it too literally now, but yeah,
Well,
yeah.
can you
But
use that?
so what we do,
Can I use this?
you go ahead, use that one. I think. Oh, there you go. So when you, I think you missed it.
If
Put
you
it back.
miss it, it doesn't work.
So
if
when
this
we-
is gone, it doesn't work.
Because there's no electricity, right? The battery has the electricity. So if you put it back there, now the circuit is open, and now when you do that, it closes because now the tape, there's
when you
tape
let
on
it
both
go.
sides of the battery, right?
Look at it. I'm pressing it, and I'm pressing.
Yeah.
I'm pressing it, and I'm.
So now there's- when you-
So when this is gone, it's just paper.
Yeah.
No electricity is in paper.
You're right.
But balloons are electricity when
Well-
you rub it on your hair.
That's called static electricity. We'll talk about that a different day. Put that back on there, yeah, like that. Now close it, and now the tape, the electric, the wire, right, touches both sides of the battery, and we've got
Let me go.
power, we got light.
Okay, so
This tape is actually very similar to the same stuff, and if you've seen those greeting cards that either play a song or do something when you open them up, this is what's going on inside those cards. And it's just there's a switch somehow that when you close the switch, you close the circuit, the song plays. So we can do all kinds of other crafts with this stuff. And so we'll show you a couple of examples of that. Here's an example of a card we made incorporating these paper circuits. Zoe drew this really cool Yoda, and we gave it to our cousin for graduation. First, a couple of things that are important to understand. One, you'll notice that the bulbs have two wires coming out of them. One is shorter and the other is longer. The short wire is the negative end, and the longer wire is the positive end. This will be important in determining how to set up your circuit. Second, if you look closely at the battery, you'll see that one side has a plus mark on it. This is the positive side. The other side of the battery is the negative side. Again, you'll need to keep track of the positive and negative ends in both batteries and bulbs when wiring your circuit. If you don't, it won't work correctly. With this card, the first thing to do was to get Zoe to draw something. She thought that a green bulb would look cool as a lightsaber, and the best thing to hold a lightsaber is a Baby Yoda. And that's what she drew. As you make your design, it's important to have an idea of where you want the bulb to go. From there, she drew out the circuit to make sure that we had it laid out correctly, including where the break for the bulb should go, as well as the location of the battery. Then we marked where the positive and negative sides of the battery would contact the tape and followed the circuit accordingly so that we could see where to put the long or positive wire from the bulb and where to contact the short or negative wire. After that, we just stuck the copper tape according to the diagram. Then, using a brass brad, we poked a hole in the card through which we could stick the bulb wires. We put the bulb in from the front, taped the wires onto the correct section of the copper tape using Scotch tape. We use Scotch tape to secure the battery as well. When you tape the battery into position, make sure that you have it in the right spot with the correct side facing up, and make sure that the Scotch tape doesn't cover the entire battery. If it does, it won't make good contact with the copper tape and your circuit won't work. When you're all done, check to make sure it works, and you are good to go. Another project you might enjoy is this traffic light build. Using 3 different colored bulbs, as well as a paper clip and a brass brad, you can learn about how switches control the flow of electricity in a circuit. The pattern for this build can be found on our website for subscription science. Thanks for watching. We hope you enjoyed the video and have fun with your paper circuits. As always, we love the ideas you share with us, so please send us some videos of the projects that you come up with for this one. Have fun, stay safe, do science, and stay tuned for the next installment of Hands-On Learning's Subscription Science.
Juice goes up to here, so the light can produce light so it can shine.
Very good. So the juice, or do you know what we really call the juice?
What?
Electricity.
Yeah, the juice is electricity.
Yeah.
Because electricity makes trees fall down. And when it's atomic night, it's helpful because it goes into our house, into there, so phones can really charge.
Yeah, it does charge our phones too. It does all that. Yeah, there's lots of electricity everywhere.
Yeah, so we're walking through, so if you cut a wire, a part comes out.
Yes.
Like a big. It's only a part, so it won't lay your house.
It was not, yeah, it's just a spark. What do you call those big sparks in the sky?
Fireworks.
You're talking about fireworks.
Fireworks.
But I'm talking about the ones, what do we call that big spark on the sky when it's like a storm outside?
Rain.
Well, there's rain, but what's what do we call that?
Lightning.
That's lightning. That's electricity too, right?
Mm-hmm.
But
lightning is electricity, so it goes into there. We call that electricity, but it's actually juice.
Yeah, kind of like that.
You want to try? You want to touch
Yeah,
it?
I definitely do. Oh my God, that's so cool.
Metal is inside wires. So metal used to be wires in the olden days, but now it is not. So metal is in, but still helpful for metal. Metal is too helpful. It goes in wires.
Yes.
The factory makes wires into the sink. So they opened it up and they put it in the wires. So that's how it's all made.
Yes. Okay.